Hello, my name is Miguel Serrano. I'm a resident of medical physics in the Hospital Clínico San Carlos in Madrid, and I'm here to defend my abstract for the do-it-yourself fair, which is called Managing High Doses in Interventional Procedures using Matlab and Dicom Radiation Dose Structure Reports. First, I'm going to show a video where you will see DIDO or DIDO, which is a software called Dicom Dose, which is able to estimate a 2D dosimetric map and the peak skin dose of an interventional procedure. This software was programmed by Roberto Sánchez. Now I'm going to show the dose interface. In this tab, we are asked for the dosimetric information of the irradiation events. As you can see in the video, we are asked for a CPS-specific format, and DIDO is able to calculate more than one procedure at the same time, even if they were done in different days. Once this data has been read correctly, we are asked for information about the specific room of the examination. This will generate its own geometry. Then we are able to introduce data of the patient. This is because DIDO has a database of 50 phantoms. Once this information is ready, we will be able to estimate the dosimetric map. This video is in real time, so as you can see, it doesn't take much time for it to make the calculations. And now you will see the peak skin dose of these two procedures summed up. In this case, as you will see now, it was of about 4.6 grays, and this is the result. Now I'm going to explain the calculation scheme that DIDO follows for each point of the map. First, let's consider we have an interventionist arc, where we have our intervention reference point and our focal spot. Then let's consider a real clinical situation where the skin of the patient won't match the interventionist reference point and the examination coach will intersect the beam. What DIDO first does is to check if the examination coach intersects the beam. If it does, it will estimate its attenuation factor. Then it will take into account the geometric difference between the interventional reference point and the skin of the patient. Next up, it will take into account the backscattered fraction, which depends on beam quality and beam size. Last, it will transform air kerma into water kerma through the quotient of energy transfer coefficients. To conclude the presentation, let's see how accurate these estimations are. To check this, we have calibrated a batch of SLEDs for different beam qualities. Then we have reproduced for clinical projections. Here you can see images from the acquisition process. And we have compared the DIDO's dosimetric map with our measurements. Here you have DIDO's dosimetric map, and here you have the difference between our measurements and DIDO's estimations. You can see the range between the 13% and the 5% difference. So we conclude that DIDO is a valid resource to start patient follow-up if the peak skin dose reaches a certain value. If you reach this point, thank you for your attention.